we are. Sorry for that. So, good morning, everyone. Thank you for the introduction. My name is Stefan Weisenberger. I'm from Germany, as you may hear from the accent. I nowadays live in Toronto. I'm a chemical engineer by background, and I work for a software company, SAP. So what we do is we provide business software for all sizes of companies, small ones and big ones, anything from demand planning to manufacturing, e-commerce, logistics, and of course financials. For many companies, that means we basically run the backbone of their industry processes. And me and my team, we're responsible to make sure this works not in a generic way, but really for the problems and the challenges that we have in our industry here. So it's around how can we work with dialogues, with rolls and sheets and fabric and yarn, and how can we model this data model in a kind of an ERP system and the neighboring processes. Today I would like to discuss a few examples about how textile companies can use the Internet of Things to deliver better outcomes, to have better customer experiences on one side, so the interaction to the customer side, but I will also put a strong focus on what's happening in the factory. So how can you use technology in a factory to have more visibility, to predict what's coming, to be better in your efficiency, to create less waste, for example. I am responsible at SAP for what we call mill industries, so that's textile, but that's also industries like paper and packaging, woven and non-woven. I will bring in a few examples of those neighbors, even if they're not textiles, because I think it's helpful to better understand of how other industries are using technology, and maybe that's something where we can take away something. So the IoT is something that, the Internet of Things is something that does not exist in isolation, or does not create its value in isolation. If you have a lot of sensors all over your factory, to actually be able to make sense of that, you need to complement that with tools like advanced analytics, big data, or artificial intelligence and machine learning. If you just collect information and don't make anything of it, doesn't bring really value. So it's this combination that helps us to see the signal in the noise. We call that intelligent technologies, how these different elements come together. In Europe, the term we use is Industry 4.0 for that, as the fourth wave of the Industrial Revolution. And the idea behind that is really a revolution. This is not a small thing. It happens, of course, in steps, but it is quite transformative. It transforms society. It transforms also. We talk about the future of work. How will our work environment in the factory change through that? And of course, an aspect is also how will that change manufacturing, for example, in the US? Will it bring manufacturing back? So that's fascinating for me as an engineer, but in a way it can also be a little scary. So will this be a positive change, or will this actually be disruptive? Will artificial intelligence improve our lives, or will it actually cause damage? Who knows better than Google? So let's ask them. So artificial intelligence will take away job opportunities. Or talking about a term you may have heard, where basically they will replace humans. Singularity, I don't know whether you heard that. There is even people looking at that. There will be a point in time where AI is smarter than humans. That can be scary. But it's also positive sides. AI will be able to improve medical treatments. AI will take the next level of automation and bring manufacturing back. Well, AI, actually, even Google is a little confused what it will bring. So let's take a look into a neighboring industry, because it illustrates the change that we actually may see happening with us. Oops, sorry, that was one too quick. Does that work? Oh, it does not work. It does, okay. If you look at automotive, maybe you supply into automotive. What we see, though, is that the automotive industry has quite changed. If you look back at what a car looked like in the 80s and what a car looks like today, the experience is totally different. I had the chance to drive a Tesla of a colleague on the highway from San Francisco, and on the highway I let go of the wheel. As a German, that felt kind of strange. Then my colleague told me to close the eyes on the highway. And I can tell you that felt even more scary. The point is, the interesting thing, it's still safer than if I would be driving. And that I found somehow insulting as a German driver, but nevertheless, it's a thing where I experience the way how much technology has advanced and how it's actually changing things, how it is in our daily life, where we see that happen. But that's a topic also we believe that we can translate into what is happening in organizations. What does a car need to have to be able to self-driving? It needs a certain level of capabilities, and I will use these as an example of what you also would need to have in a company to be able to be an intelligent enterprise, as we call that. And number one of that is visibility. This is how a car looks like at its environment. It sees with different senses. It does not just have its eyes, it has LiDAR, it has radar, it has a number of other sensors that basically create visibility about what is happening in the surroundings. Today we have tools at our hands that were not there 10 years ago. So we have the possibility to, a bit like in Google Maps, to see the full picture of what is happening in the value chain. But we are not just on an aggregated level, but we're actually able to see the full picture in the full granularity. So we can see across the value chain what each individual garment is doing, where is inventory, how every machine is behaving, and create a complete picture of that. That's something that was not possible before. You can have the same thing also in the shop, and you can have the same thing like in here. So you have the full transparency and visibility about how everyone is thinking about this conference. You will get asked through the app, and she will know exactly what you think. That's something that's possible today. Beyond visibility, knowing what is happening, the second most important thing is what we call focus. And the idea there is really the capability to be able not just to sense everything, but really to help technology focus you on the things that matter. In that example, let's hear that the car knows of all the different things that it sees. It's this bike driver that is actually creating a danger, and this is where I would need to focus the attention of the car on. Intelligent technologies like machine learning helps us to recognize unseen patterns that we cannot see with our senses in that big haystack of information. Machine learning helps us to connect the dots, bring the information together, and see correlations. So we can automate everything that is repetitive, and we can have people, and that's really where work is also changing. People are no longer focusing on the repetitive part, but people are focusing on the exceptions. You can have that in a factory where you can basically say everything runs by itself, except something strange is happening and you need a human to actually intervene. So I will give you an example for that later on. So the last element, and I would believe that is the most important one, especially if you talk about a factory context, is this agility. This is the ability to understand something is happening fast enough that you're actually able to do something about that. So if you know quality is deviating, if you know a machine is having problems, and you know that a day after the fact, or even a week, if you look back into your reporting, it's a problem. You lost time and you can't do anything about it. The quicker you know something, the quicker you're able to do something. And is able to look ahead. People is not seeing that. but the machine is able fast enough to put in the brakes so that you're actually stopping in time. It is helping in the car, but you can have exactly the same thing as well in manufacturing. So we have discussed that, for example, in the context of predictive quality or predictive asset management, to understand if something is going wrong and really stop and counteract as quickly as possible. And that is one of the elements where technology really is helpful. And finally, where we think about what is the end state, the fourth of these components is self-learning systems. So that you're not just seeing things, you're focusing on the right stuff, and you actually are quick enough to do something about it, but you're constantly learning as an organization. You're adjusting parameters with every exception that you see and get smarter and smarter as we go. This is the self-driving Tesla, but the interesting piece how that works is that every car senses its environment, every car is recognizing what is happening around and playing that information back into the central system. The central system learns from that and is transferring that information back into the individual car. So a car will learn from things that are actually happening somewhere else. And that is one of the things why this is getting and accelerating so fast. Is this interesting for us? This is cars. It is. If you are a manufacturer of, let's say, knitting machines, you can, and you're not just monitoring one knitting machines, but you're monitoring all knitting machines in the world that you operate, you can actually give pretty good predictions about what's going to happen in production. So there is a connection about if you bring together information and you're able to identify patterns in a large pool of data, you're actually able to give recommendations and add value to the person who is operating that machine. So let's change pace a little bit. Let's look specifically at textiles. Yesterday we had a brilliant overview about what is happening in the market, how that is changing, what are the market dynamics and trends. And you know that a lot better than I do. I'm a chemical engineer, you're in textiles. Point being, I've selected from a report, I looked at a few points where I believe technology is really helpful to make a difference. And one of the things we discussed yesterday is the question of microfactories, about the ability, yesterday it was around digital printing as a tool to do that. And the idea there is really to say, how can I use on-demand manufacturing, agile manufacturing, or make-to-order manufacturing in an industry that is normally more something that runs at mass scale? Is that possible? And I would say, if I look into my neighbors in discrete manufacturing, there it's very common. You configure something online and you send that information to either EP system, it sends it to planning, sends it to manufacturing, it goes down to the machine and the robot starts to be working after 30 seconds. You can basically have this full integration, totally automated, happening immediately. This is not just a question about the machine you're using, obviously. This is also a question about how are the different systems or islands of information, how connected are them, and how good the information is actually flowing from A to B. We discussed yesterday also about how paper industry may be a little bit more advanced in this integration. This is something we see with customers, that they basically say we want to have touchless order entry, touchless MRP and planning. We have an optimizer running and basically the whole flow should happen except in exceptions, basically directly, without human intervention. So there is an element of intelligence in if you want to go to microfactories and you want to do that at scale. The second interesting question is shoppers are looking for same-day shipping. They want to have 80% want to have same day, and 60% say they even want to have it faster. I can relate to that. I was ordering shoes online before I came here, and I hoped I would have them. They are now in Toronto, and I'm here. It's not helpful. So that is a topic, that's a differentiation, and this is also an important topic if you talk about the younger generation buying. This is important if you talk about the combination of online commerce and in-store commerce. How can you create transparency about, is that available, where is it available, how can I get it to you, and how quickly? You need to really have a 100% overview of what is happening in inventory in the store, and not just in one store, but in all stores, and maybe even in your channel partners. If you have that, you can be much better about how to deliver and how to promise. Other topics is interesting with the increase of e-commerce. What is that doing to us? That means we have certain things that easily work in a store, somehow need to work on a mobile phone or need to work at home. So we need to complement that with intelligent technologies to basically make sure people are ordering the right stuff, people are getting recommendations, people are helped in the way they interact. And finally, down there on the bottom right, it's a topic that's close to my heart. This is a question about what attaches or links people to a brand. This is no longer just a product, this is a story, this is a question about purpose, what a brand stands for. And this brings in certain technical requirements. How can you prove that your promise is true? How can we, yesterday when we were walking in the hallways in the university, we saw research about microplastics that an apparel manufacturer is doing together with the university here. We saw about recycling and the ability to use recycling fibers in textile manufacturing. When I buy something online, they tell me this is made from recycled fiber. This is made without slavery. But can I trust that? And will people believe your promise? And this is also an element where technologies, especially topics like blockchain, really can help to create this link from the consumer to what is happening in a multi-tier textile value chain, really we can sometimes call it sheep to store. So basically to create really a link between all that. So let's first look a little bit at customer experience. And I liked your little voting thing. I got my little voting thing here as well. This is interesting because this is about customer feedback. This is about what we call experience or sentiment. This is what people think about products, think about buying online, think about buying in store. And this has two elements. I mean, you can send a survey and you get some information, but the tricky thing is how do you actually connect that back into a process and change something? And this is something where we're currently looking at, and I'm a fan of roller coasters and an engineer, so I like that. This is basically talking about two different sets of data. One is about what an engineer looks at. This is velocity, this is acceleration, this is g-force, this is really how a coaster is constructed. This is solid business data. In our terms, this is about quality, this is about order volumes, inventory. And then there is a second element to that, and that is really the emotional and the sentiment side. And one of the points that I like about that is if you can connect that, if you know where people scream, if you know where people like something or where people are frustrated and basically cancel a shopping cart, if you can connect that, you have a possibility to not just sense things, but you also sense about what people are feeling and how they interact with that. And actually, much of that is the same analytical technology behind that. You just do not have a sensor that is attached to a machine. You basically have a sensor that is attached to a phone or to an emotional person. The initial goal behind that is to make fashion more accessible and more interactive. And this is something that we piloted with Bachelor Mishka. This is pretty similar to what we're doing here. Something to use in a fashion show. It's a possibility to crowdsource emotion, to interact deeper with the people that are in the audience. And it basically works like that. You beforehand take a 360 photography of a look, and It uses machine learning on that information. And then if someone goes on the runway, you can scan him. You can say, oh, this is cool. I love that. You can say, this is not so much, or this is just, I like it, but it's not overwhelming. You can give feedback with everyone new entering the runway. You have a possibility, it appears here. People can scan the person and can say, wow, this is something I like to have. Interesting piece here, it's creating a very direct interaction to what is happening in the show. So the audience is much more participating, they're not just watching. Second element, you get quite interesting insights because you tell before you enter the app whether you're just an influencer, whether you're a brand addict, or whether you are a buyer. You get information about which of the different looks are actually top of the list and something you should immediately produce in larger scales, and which of those are actually on the lower end. That's a level of granularity of information you normally do not have. We did that with Battery Mishka, we did that with Siriano. Actually, we were doing the same also with Cirque du Soleil. If you have a show and you want to interact with that, you have an effect, you want to trigger an effect, and you want to get feedback whether that was good. If you have a survey at the end, you have an aggregated view that doesn't tell you anything. If you have it directly in the moment, you know about how this specific thing was good or was not good. It's quite interesting. This is not really about what's happening in the factory, but this is really about how you interact in a store, how you interact in a fashion store, how can you create a relationship to consumers that otherwise are difficult to get with normal advertising. Another interesting point is how can you use technology in a store. There are many stores of the future or concept stores where technology is tried out. I brought one or two examples that show a little bit what you could do. Something I like, which we did together with a few companies, is a smart fashion tag. This is basically connecting the thing world of a specific garment to the business world. Here, this tag is working with e-ink, so it doesn't consume a lot of electricity. It knows its position, where it is in the store, and it also provides information. It provides information on price, it provides information on size, it has a little QR code for the consumer to basically interact with the product and get more information. And the interesting piece, as this is e-ink, it gives you the flexibility to actually do more with that. So while you have the garment in the DC, the price may be a certain price point, but if you put it in a store, you may actually would like to differentiate the price by store. You may want to differentiate the price by size or by color. You even may want to go the way that Amazon is doing. They are changing the price of products multiple times over day to understand price elasticity and to be much smarter about how much they can actually price something. That is very hard to do if you have a printed tag on a product. If you have something that is live connected, that has an electronic tag, you have the possibility to play with that, to say, what would happen if I lowered the price? What happens if I increase the price? And you can thus have more influence about what is really happening. Another thing which I liked, I tried out. I'm normally not the guy who tries out lipstick, but in this case, I actually did that. This is a nice example how to create also a more dynamic interaction with the product. Here, it's a smart mirror that solves a problem for cosmetics. If you want to try out a product, it requires, first of all, to have a number of product samples. You need to make sure they are looking okay, they're clean, and how many lipsticks do you typically try on? I don't think you would go over 5. I didn't try physically any of that. But the interesting thing with the smart mirror, when I pick up a lipstick, the smart mirror switches on and basically uses augmented reality to draw the color on myself. I tried that. I'm not scared of that. It is fun to play around with. It's really something that is engaging. It's nice to do. But it's also, if I don't like the color, I can put it down, I can pick up another one without needing to clean myself or being smeared all over, which would happen to me. Which is one thing. The interesting other thing, besides the experience, is what you can do with the data. And here we're back into sentiments and measuring what people are feeling, what people are doing with the product. Here, this is about how often was a certain color picked up compared to another color. How long did people interact with it? And then compare that to your sales data. Was it actually bought? Or was there a reason? It may have been too expensive. People liked it, but they say, oh, nah, rather not. So this gives you a lot of direct feedback in a store to really understand in a very granular fashion what is happening. And it's fun also for the people working there. You can use augmented reality also to enhance product information. You can use a normal phone to scan a QR code. You can in this example, we used basically image recognition. So we're just looking at the picture of a product and we draw information from online reviews. We draw additional product information about what the product is like. I would have so loved to have that when I'm shopping for running shoes, I can tell you. I'm not having the best feet, so I have something they call pronation, I think. So I'm doing something like that. So I need something that is supporting me. I'm running trail, I'm running on street, and I'm looking something that is reviewed positive. So how can I find it? I can wait for a store assistant to actually talk to me, but in some shops that may take me 20 minutes until someone recognizes I'm there. If I have a possibility to get the same information directly, this is quite interesting. And if I have the possibility to translate and bring that information also to an online shopper, even more interesting. Again, changing the interaction, providing more information, and thus avoiding that people send back something that they don't like. Talking about shoes, if you say 80% of apparel and footwear will be sold 2030 online, and today 70% of returns are due to size issues, this is a problem. And this is a problem multiple research institutes, one I worked with in Germany, are looking at other ways to make this better. And technology can help in that as well. It can help in the shop, but you can also do the same. It can help at home. This is a startup that we work with that runs on our platform. They are basically having the idea to give an intelligent size recommendation service. That means the consumer can use tools they have at home, like their phone, and a modern phone is quite smart. It can actually do a 3D image of your face to recognize it's you. And you can use that sensor for a number of other things than just opening your phone. You can use the same to basically scan a foot and understand the size. You can do that, of course, with sophisticated equipment in store. But you would not have that if you're shopping online. So the point is, can you use technology like that? Can you apply to that information you captured machine learning and combine that with product information and then embed this into a store? And this is something those guys are working with. They are collaborating with online retailers to basically make sure that they can use additional information to be smarter about what you choose. Others I talked to, they are looking into returns. Can you determine the actual size someone has and body shape by what products they keep and what products they return? You can. It's also a machine learning problem. Pretty sophisticated. You somehow need to have body models and you need to map the different brands and the different size information back to that. But it's something you could do. And then there's a third topic. This is product identity. And this comes back to the purpose-driven generation. People that would like to know the story and the history of a product. There's been an initiative ongoing. I'm not sure you saw that. This was called Who Made My Clothes on Instagram and on Twitter, driven by a group, Fashion Revolution. And their idea was basically to that consumers ask the brands, how was my garment manufactured? Where was my garment manufactured? By whom? Does someone have to suffer because I want to look good? There is a response, quite a strong response about what is happening online, how people are actually posting pictures of their garment. And we have brands that respond online to that and say, okay, this is a picture of someone who actually manufactures that, so there is an interaction. But is that trustful? Is that something I can rely on, that this one is really coming from this specific person? You can have, of course, something like that. You can have a label attached to it that tells a story. You say, this is organic or recycled fiber, this is certified dyeing, and this is fair trade, or even made in the US. But do I trust a piece of cardboard? I don't, honestly, because I've seen so much greenwashing and so much cheating happening in the industry. So I trust rather intelligence or something that people cannot cheat. And blockchain is here a key technology that is helping that, because they say blockchain is an immutable thing, so you cannot change stuff. It's transparent for everyone in the chain, for the consumer and for a certifier, so you can basically look at the entire value chain and the entire flow of a product, and you cannot trick about that. That's something we do with diamonds. Where do they come from? Is that a blood diamond? Does it have a bad history? We do that with currently with cobalt and coltan. Does it come from the Congo, or how is it sourced? Is it from a mine where people are, where kids are mining? We do the same with expensive spare parts, where we say, am I sure this is the true spare part, or this is something that is that someone else manufactured? And especially interesting is we do that also with pharma. So if you buy expensive cancer medication, you want to make sure this is the true thing, and this is not just a cheap copy. It could be dangerous to you. And the same use case you would have not just around sustainability, but you also would have the same thing if you talk about authenticity, about high-end fashion. Really expensive luxury items, you want to make sure this is not a copy. As a buyer, but also as a brand owner, you want to make sure that you can prove this is authentic. And this is basically using the same technology. This is the combination of sensing and connecting physical objects to the blockchain, and then making this information visible to the consumer. This is an example. I don't know whether you like tuna. I like tuna, but
we track every piece of fish. The best part of this is how easy it is for the consumer to use a cell phone to scan the QR code, and it tells them exactly the type of fish, when it was caught, where it was caught, and if it's fair trade certified.
So I know you're not in fish, but I think you get the point. It's about the consumer having transparency. We are at the point where we say this is something we can do at scale across industries. We can embed supply chain information and link that to blockchain to basically create this kind of transparency. Eon is a startup that we work with. They have just launched this. They call it a digital identity of a garment, and they're collaborating on that with big brand owners and retail chains to have the idea to have a digital identity, to just not have a product name, but to give an identity to each individual piece of garment. And that is interesting because it gives information about transparency, as I said. It also can give information about composition. It's basically a digital twin. We used that term yesterday when we talked about it. Here it's not a technical digital twin that helps a engineer or a designer to craft that into the perfect model and to reflect all the optical appearances of that. This is more a digital twin that is for the value chain and the consumer, to give transparency about the story of a specific item. It has several elements to actually work. Number one is you need to create a link. If you have something digital, a digital identifier, you need to link that to the physical object. So you need to have some sort of a tag that is attached. That can be an NFC, that can be RFID, that can be a barcode, a QR code. It's a technical discussion about whether you embed that into the garment, that it actually stays after someone cuts off the tag. So we're talking about RFID threads, for example, to make sure after a certain number of washings, it's still existing and you are still able to retrieve that information. That is more a technology and engineering question. And then there are two elements. One is the birth certificate, to say how it was manufactured until it left the factory. And there is a second element, which is a bit more advanced. This is like the passport or a travel log. How did that garment journey after it left the factory? It was sold, it was returned, it may have been resold, it may at a certain point be shared, it may be rented, it may be recycled. So there's a journey from cradle to grave of that, where you can basically follow with a digital identity. Why is that interesting? It's of course the first use case I had with the tuna. This is about providing more information to the customer. But this is also interesting in relation to supply chain. This is quite interesting if you talk about policy and compliance. If you want to prove that certain chemical information or certain types of fiber or certain type of chemistry was used, and you want to prove that, and you want to make sure this information is visible to people, it's also a way to do that. And there are a number of other use cases, like if you go into not buying, but into rental or subscription, how can you trace an individual garment and know where it is? This is one way to actually achieve these kind of models. This is about what is happening outside the factory. Let's now take a look inside the factory. Talk about smart factories, digital factories, Industry 4.0. This is, I would say, one of the biggest things where we can really achieve something. This is an example from a company, I would say they're at the border of what we do in textiles. They're a home textiles and carpet manufacturer, but it is a nice illustrative example of something that we see happening in a number of different industries. It's very advanced in paper. I would say every second paper company I talk to are using that currently in one or the other factory. And the idea there is to, thinking back of what I said in the beginning, to create visibility, to bring information together from different sources to be smarter about what you do. So what was the problem of Mohawk? Mohawk are manufacturing home textiles, and it's a thing we discussed yesterday at length, the question of color and the question of staying true to your color and not having, I think it was yesterday, 6 weeks of navy, where we were trying to find a certain hue, a certain color, and actually making sure that you understand why color keeps deviating from what you would actually like it to be. Their problem was that if you're having, like here, a floor where you have tiles beside each other, they should look the same. If the customer sees they are not the same, Mohawk will get them back. They will rip it out, they will need to scrap it. It's a huge lost value, and it's also not very good for the customer relation, because it basically means in a room like that you would have no floor instead of a beautiful floor. And this is hurting. This is worse than a normal garment. So the problem they were not able to really track down. They said, what's the reason? Why do we have deviations? And is machine learning, data science a possibility to solve that problem? And we said, maybe. Let's try it out together. The tricky thing with that is we're looking at a multi-level production. So if a tile ends up here, this was on a roll, this was cut, this was manufactured over multiple manufacturing steps. this piece of fabric traveled across a number of different production steps at certain points in time. And there was a sensor there was a sensor there was a different sensor there. You somehow need to bring all that information together to really scratch your head and use machine learning then to understand what you can do with that. Second tricky thing is these are different data sets in a factory. And I don't know, maybe you're much advanced, but the guys I talk to sometimes, they have 40 different plan systems. There is one for this kind of recipe, there's one for quality, there is one sensor that is basically capturing camera information that is constantly looking at the fabric. There's another one that is looking at process parameters and another one looking at maintenance. I had a discussion yesterday about digital printing and how you measure how the printer head is changing over time, or how the needles in a knitting machine change over time, and how you model that and bring that into an overall picture. So it's not just a big data, it's a heterogeneous data problem. And this was not solvable, I would say, 10 years ago. You would have process engineers looking at the individual pieces. Now we can look at the big picture and correlate that and bring that together. So what we did with them, we sat together with our process engineers, and we were doing, first of all, something like a root cause analysis. We tried to see whether we can say, if there's a customer complaint, can we track that back into something that was happening at a specific point in time in the factory? So this is a bit about traceability. So you need to create that link across your internal and external chain of process steps. And this is also about a data model that you need to introduce there. The second thing is, well, if we can do that, and if we know these parameters actually, or this, normally it's not just one, it's a combination of several, this created a certain specific problem, then we can help the process engineers to operate a certain machine in a tighter control range, or we can tell them, you should be careful if that kind of thing is happening. So to make basically the statistic process control a little smarter in a specific area based on what we know. So number one, we did that with them and that worked out. So that was good. The second element is, well, if we know what has triggered a complaint in the past, can we actually turn that around? Can we look at something, talking back about agility, about something that happens real time on a machine in the factory and predict that it will cause a complaint later on? And that was quite interesting. So the idea there is, can I catch on a machine a situation where I know this seems to be okay with what I look at it within the machine parameters, but based on the bigger model I have, this is a situation that is probably deviating if I predict it into the future. And this is pretty powerful. We've done that with Mohawk and it worked out. There is a certain confidence interval, but it gives you a situation to catch things. You remember the picture with the car accidents? You recognize things before you actually crash into a problem. This time advantage is quite helpful. But I need to be honest, I'm a product manager and not a sales guy. Sometimes this works and sometimes this does not work. Sometimes you're lacking information. We had the discussion with a paper manufacturer and they needed to have product quality information for every bale of cellulose. They were not having that. They would need to introduce more quality checks, and they said, this is interesting from an engineering perspective, but this is not viable. This is too costly. We will not do that. So this did not work out. We had others where we said, okay, we can predict this is gonna create havoc, but we were able to do that 30 seconds before it happens. No one was able to do something about it, so we were not fast enough. So it depends a bit on the problem you're looking at, and this is not all wonderful and solves everything, but it solves a number of problems. We had other customers that were able to basically say, in the non-woven industry, where we were able to say we can achieve a product quality with less input material, same quality, less raw material input. We had others where we said, let's not push up quality, but let's push down cost of quality, where we basically say, let's focus. We help people focus on the likely critical pieces and the critical situations. So we change the way we run quality and bring down quality cost to a quarter of the original value and still achieve the same quality level as before. So this can be pretty powerful. We've seen that in metals, we've seen that in paper, we see that in non-woven, and we see that also in, here for color deviations, we were using the same also for capturing quick enough problems with knitting machines. Also a topic where you say you don't want to keep manufacturing if there's a defect somewhere upstream. If you are brave, you can actually take that one step further. This is something I have not seen in the textile industry. I've seen that in an old-fashioned way where basically people were indicating we have on this roll of fabric so and so many defects, and sometimes someone actually, back in the old days, marked that on the fabric. Nowadays, if we talk about digitalization, it's a way to say, okay, my product is very good, but it's not perfect. Quality is not homogeneous across the entire size of a roll of fabric. And I know that, but I actually share that information with my customer. That works with some customers, and they're happy to say, okay, this is good. If you cut it out, we lose a lot of value, and you make the product more expensive. If I optimize around that defect, it's actually much smarter if I do that. And so we had situations where basically the next step in production were doing their piece optimization and their geometrical optimization based on the information that was shared from their supplier. You can do that. It's basically creating value for both players, but it also would require that both collaborate. And you can do that with some. If you try to do that with the German car manufacturing industry, it will not work. They will say, if this is not perfect, go away, and we will punish you. But with some, it actually works. So it's more a cultural problem than actually only an engineering problem. So let's rethink. We started off with visibility, focus, agility, and to then move into something like a self-driving, self-running, sometimes we call it lights out factory. What do we need to have in place for that? We call that the intelligent enterprise at SAP, and the idea behind that is there are certain ingredients that you would need to have, and there are certain ways how you run IoT projects that we observe. I would not even say recommend. And maybe that helps you if you think about topics like that to guide your thinking a little. There's one stuff that I would say where we know we have a very standardized process that we understand very well, where we understand the data structure very well, and that is comparable and standardized across industry players and across companies. This is something that I would see in our homework. This is what we call embedded intelligence. This is like with a Tesla, you don't have to worry about how that car drives. This is something that happens basically because the software provider is making sure this is happening. And another example in that direction would be blockchain. Connecting blockchain with the supply chain is something we do. We have done that, and this is part of our standard product. You can use that, and you can buy that off the shelf. Still, you need to make sure that your player are working in a way that this is supported. But technically, from a product perspective, we provide it out of the box. Then there are other topics that is here on the extend side. I would say this is like predictive quality. This very much depends on your factory setup and the problem that you would like to solve. There are common parts and things that are the same really across the different use cases. This is where we provide something like, call it an innovation kit, an accelerator, a combination of tools and algorithms to make this quickly work. But it requires some engineer to sit with you to actually analyze the situation. And then there is what our marketing folks call transform, open innovation. This is the crazy stuff. This is things like using phones to identify body sizes and all kinds of other things. This is out of the ordinary. This is something where you basically need to have a platform that provides a robust technology. But this is something you would basically need to build from scratch. Us, as SAP, as a software provider, we build all 3 use cases on the same platform. So we use the same tools. We use that to embed the technology directly in the standard process. We use that to build the innovation kits. So it basically uses the same common parts. But if you mix that, you somehow need to figure out how you're going to do that yourselves. So what's your homework? If I can give you a homework, I'm not a teacher. I think it starts on the top. If you're talking about an intelligent enterprise, you need to make sure from order taking into planning, into manufacturing, into shipping and billing, this runs directly integrated if you want to go in the future. Then you add in certain areas intelligence, and then you also need to have something that helps you to connect to this real world, either by asking consumers or by connecting with sensors. This is where you have this kind of data management or sensor integration. We call it the intelligent enterprise, but I don't know how you call that. The idea is to make it work as one, to be able to automate. If you have 40 different databases and 6 different systems in different factories, this can be very tricky to do and pull off. But we've seen companies that are actually quite advanced in that are basically running that. This is not just a vision, this is something really happening already today.